Next example. The angle between lines x minus 2 upon 1 is equal to y plus 3 upon 2 is equal to z minus 5 upon minus 3, and x plus 2 upon 2 is equal to y minus 3 upon 5 is equal to z plus 3 upon 4 is. Here equations of two lines, they are in Cartesian form. We have to find angle between lines. If we know direction ratios or direction cosines of two lines, then we can find angle between them. Here numbers in denominator, they are direction ratios of two lines. For first line, direction ratios we shall denote by A1, B1 and C1. A1 2, B1 is negative minus 3, C1 5. These are the coordinates of point for first line. We want direction ratios. Numbers in denominator are the direction ratios. So A1 1, B1 2, C1 minus. For second line, direction ratios. A2 equal to 2, B2 equal to 5, C2 equal to 4. Cos theta, it is given by A1 A2 plus B1 B2 plus C1 C2 divided by under root A1 square plus B1 square plus C1 square under root A2 square plus B2 square plus C2 square. For convenience of calculations, let us find sum of product of direction ratios first. 1 into 2, 2. 2 5s are 10, minus 3 into 4, minus 12. 12 minus 12, 0. Now here we need not find under root A1 square plus B1 square plus C1 square as well as under root A2 square plus B2 square plus C2 square, because sum of product of direction ratios of two lines is equal to 0. It means that lines are perpendicular to each other, and as lines are perpendicular to each other, angle between them 90 degree. So here answer is option D. If sum of product of direction ratios not equal to 0, in that case we have to use the formula. So we have to find other values also. In this example, the distance between the points A 1 minus 2 3 and B 2 1 4 is. Coordinates of 2 points are given. Both the points are in space because every point has 3 coordinates. We can use distance formula. We have seen in 10th standard only distance formula, which is applicable for 2-dimensional geometry. Now we can apply it for 3-dimensional geometry also. Distance AB, it is given by under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square equal to under 2 minus 1 whole square plus 1 minus minus plus 2 whole square plus 4 minus 3 whole square equal to under 1 square 1, 3 square 9, 1 square 1, root 11. Here answer is option B. Next example. Direction cosines of two lines, they are proportional to the numbers 1, 2, minus 2, 2, 3, minus 6. Then cosine of angle between them. So here we have to find cosine of angle between two lines where numbers proportional to direction cosines are given. Numbers proportional to direction cosines, they are nothing but direction ratios. For first line, A1 1, B1 2, C1 minus 2. Direction ratios for second line, A2 2, B2 3, C2 minus 6. For convenience, find sum of product of direction ratios. A1 A2 plus B1 B2 plus C1 C2 equal to 1 into 2, 2 plus 2 3s are 6. Product of two negative numbers, positive. 12 plus 6, 18 plus 2, 20. It is not equal to 0. Means lines, they are not perpendicular. Then we shall find under root. A1 square plus B1 square plus C1 square equal to under root 1 square plus 2 square plus minus 2 square. 1 plus 4 plus 4, 9. 9 is perfect square. Square root 3. Under root A2 square plus B2 square plus C2 square equal to under root 2 square plus 3 square plus minus 6 square. 4 plus 9, 13 plus 36, 49. 49 perfect square. Square root 7. Put the values in the formula. 20 divided by 3 into 7. 20 by 20. And we have to find cosine of angle between them. Means we have to find value of cos theta only. So here correct option is answer C. Next example, equation of x-axis is, and here lines, they are in Cartesian form. To write equation of line in Cartesian form, what we should know? Coordinates of one point on the line and direction ratios of that line. Instead of direction ratios, even if we know direction cosines, then also we can write equation of line in Cartesian form. X-axis passes through origin. So origin is one point on the line. So x1 0, y1 0, z1 0. We can find direction cosines of x-axis. Before that, direction angles of x-axis 0, 90, 90. Direction angles of a line, they are angles made by the line with positive coordinate axis. Then direction cosines. Cosines of direction angles. Cos 0, cos 90, cos 90. Cos 0, 1. So we have got direction cosines and coordinates of one point. X minus 0 upon 1. Y minus 0 upon 0 equal to Z minus 0 upon 0. Answer is option B. Next example. Cartesian form of equation of line. P bar equal to I minus j plus lambda into bracket 2i plus 3j minus 4. Observe equation of given line. It is in vector form. And we want equation of line in Cartesian form. So we should get coordinates of one point and direction ratios. In first bracket, it is position vector of point which lies on the line. Then its coordinates. Coordinates of point, they are coefficients of I, j, k. Coefficient of I, 1. Coefficient of j, minus 1. Term of k is absent, so coefficient of k, 0. It means that this line passes through given point. Then direction ratios of line. This is a vector parallel to given line. In that, coefficients of I, j, k, they are direction ratios. 2, 3, minus 4. They are direction ratios of line. Then equation of line. X minus x1. x1 is 1 upon a2 is equal to y minus y1. y1 itself is negative, so minus minus it becomes plus. Y plus 1 upon b3 is equal to z minus 0 upon c is minus 4. So here answer is option A. Here answer of